Hi, let's start our second day on learning about the standard normal distribution. Today we're going to really take everything that we learned yesterday and put it together to solve some real-world problems that involve distributions that are normal. Our first example, we are talking about the heights of college-age men. The mean of those heights is 70.1 inches. And the standard deviation is about 2.7 inches, so quite a bit of variety there, really. The question asks us to find the probability that if we picked a college-age male at random, we'd get someone who is taller than 70 inches. We have to approach this thing in stages, perhaps, is a good way to say it. We don't know about the probability of 70 inches, and we don't have a tool to tell us that. We have a tool that will tell us what the probability is of getting at or below a given z-score. Well, I think our first thing then has to be to turn our data value into a z-score. And you'll remember from yesterday that the formula for that, z is equal to, and it's data value minus mean divided by standard deviation. So for this particular height, 70 minus 70.1 divided by the standard deviation of 2.7 inches. That comes out to be negative 0.04 roughly, negative 0.04. So this would ask us then to find the probability that we get a z-score larger than that, because we want to know about somebody who's taller. So we want the probability that z is larger than that negative 0.04. Well, I hope you'll recall from yesterday that when we have a greater than sign here, that's the time that we subtract. So we want to look at 1 minus the probability that z is less than negative 0.04. In pictures, we're looking for the probability that somebody is just barely under the mean and above. So if this score is negative 0.04, then we want to think about taking the area of the entire curve, 1, and subtracting out the part that we don't want, what's under 0.04. That's found on the z-chart. So will you look that up, please? I checked my z-chart, and the probability that we hit at less than a negative 0.04 for a z-score is almost half, which you would expect. It's just under half. So we're going to subtract that from 1 to come up with our probability that we get someone who is 70 inches or taller. Comes out to be around 0.516. So there's a 51% chance around, or close to 52% chance, that we will get a randomly selected college-age man who is taller than 70 inches. And you've done the entire problem here. You turned a data value to a z-score. You used the table to find the probability associated with that z-score. It's worth a second try. In this problem, we're talking about a distribution of test scores in a physics exam. They were distributed normally, which really, folks, that doesn't happen that often. But in this case, it says that the average score was a 78 with a standard deviation of 7. Our student, Brian, had a score of 86, and we want the probability that if we pick another student at random from his physics class, we'd get a score of 86 or less, his score or less. First, we have to find the z-score for 86. And I'm going to ask you to pause the video and do that right now. That's around 1.14. Once we know the z-score, then we can think, okay, we have a z-score of about 1.1, so it's out in here somewhere, roughly, and we're asked to find that we get a probability of landing there or less. So our probability statement is going to look like this. We want the probability that z is less than 1.14, and we're in luck because that's what our table tells us. So what we do is look up the probability that z is less than 1.14. Will you go to your z table and find that, please? Well, I've looked at mine, and we are looking for a probability that we get under, which is exactly what our table says. So I looked up that probability associated with a z of 1.14 and found around 87% of the time you'd get somebody whose score was 86 or less based on this mean and standard deviation. We want to look at a second type of problem today, and this involves working backward a little bit. Using that same situation, Brian's physics class, where the exam had an average of 78 and a standard deviation of 7. This asked us to find the score that it would take to get somebody at the 90th percentile in his class. Well, if we want to be at the 90th percentile, folks, that's way out here. That would mean he has to be above 90, or this score would have to be above 90% of the people in the class. So this time we know the probability. This is 0.9. What we want to know is the z-score. So this is a work backward problem. We got to find the z-score that traps 90% of the data under it, 90% of the probability below it, and then work backward to turn that z-score into a data value. All right, I know that you've been thinking about this already. Our table tells us the probability that we land below, right, some z-score. So what we have to do is look in the body of the table. We want to get as close to 90% as we can, 0.90. Find that z-score and turn it into a data value. Will you pause the video and try that? All right, I got a z of around 1.28. That's as close as I could come to getting 90% of the data underneath. I looked at the probabilities in the body of the table, read the z-score. I need to turn that z into a data value, and if you recall from yesterday's work, what we said is a data value is equal to, and it's the z-score times the standard deviation plus the mean. So I think we have enough info. We need our z-score, 1.28, times the standard deviation in this problem, which was 7, added to the class average, which was 78. And working out that math, it says that we'd have to score around 87 points to be at the 90th percentile, which is pretty close. Okay, Brian actually was pretty close to that. One more try. Okay, now we're going to talk about the heights of college-age women. The average here is 64.8 with a standard deviation of 2.5. If you'll recall, the men had a slightly larger standard deviation than that, more variety in men's heights. We're going to find the height that 35% of females fall below. We want the 35th percentile. That is, we are looking for 35% is less than half. So a z-score that traps 35%, once we know that z-score, we can turn that into a data value. So find the z-score that traps 35% of the probability below, and then turn that into a height. So I'm going to ask you to pause the video, go back to the body of that table, looking for as close as you can get to 0.35. Based on what I saw, that z-score is really close to negative 0.39. Negative 0.39. I'm hedging my bet a little bit there. I had to check my table and make sure. The percentage there was 0.3483, which is 17 steps away from 35. The next closest one was 0.3520, which is 20 steps away. So negative 0.39 is the closest that we can get. Now we turn that z-score into a height following the formula that you did just a moment ago. That height will come from taking the z-score times the standard deviation, adding the mean. Will you pause the video and find that for us, please? Or that height, sorry, that height is about 63.825 inches. If I did the math right, and I hope I did. I got to tell you, I'm not there, folks. Okay, that's it for today. We're going to ask you to get out there, try the U-Try. We'll see you in school.